I'm a 4.0 pre-med, and one thing about me is I study smarter, not harder. And I make mnemonics, and I have all these techniques, so hopefully you guys are going to be able to benefit from them. In the last video, I introduced to you guys the chair conformation, and this is something that's almost like trips up everyone when they're beginning organic chemistry, and they're like, how am I supposed to do this? What is this? And I'm telling you guys, it's not that bad. It's weird and funky and all that you want, but you know, it's okay. So as a quick recap, I showed you guys my trick. So first thing I would say is like, okay, I'm gonna put a bold and a dash in everything, and whatever's in bold is going to go up, and whatever's in dash is going to go down. And the way that you're gonna find out if it's axial or equatorial is like literally, so here I put axial, then equatorial, then axial, then equatorial. And notice I'm doing this on all the dash. I'm not doing axial. No, I'm doing one bold is axial, one bold equatorial, one bold axial, one bold equatorial. And then if this is axial, then this is going to be equatorial. And then I do equatorial, axial, equatorial, axial, equatorial, axial on all of the dashed portions. Then I said that you're going to have two, because in the same way that this could be in the axial position upwards, it can also be in the equatorial position upwards as well. And the last note that I made in the last one is that whenever you're doing a ring flip, again, axial goes to equatorial, equatorial goes to axial, and equatorial is more stable, it's less energy, and it is favored. And the axial position is not favored because of steric hindrance and diaxial interactions, and it's always better to put the larger group on the equatorial position. Now, going into this video, as I promised, I was going to give you some examples. So again, I'm doing the same trick. So I'm going to put my bold and my dashed. In this particular instance, this is cis, and therefore both of them are going to either be both bold or both dash. But for me, I prefer to put it in bold, so both of them are bold. And again, bold means that they're going upwards, right? And so I have my bromine going up. Oh, again, I did axial equatorial, so my bromine is going to go up on axial, and my methyl group is going to go up on equatorial. And again, this going a straight line up or a straight line down is axial. And then this kind of diagonal line is known as equatorial, just for those of you that are confused. I keep saying axial and equatorial. Okay. And in the same way that I have this, technically, this position could be an equatorial, and this position could have been an axial. So that's what this is going to show here. This bromine is in the equatorial position, and this methyl group is in the axial position. And so now the decision comes, who is going to get priority? Is it going to be the bromine in equatorial position, or is it going to be the methyl in the equatorial position? And the methyl is the larger group, and therefore it is going to be the more stable on the equatorial position. So this is going to be your preferred chair conformation if they ask. Now, I'm not going to leave you hanging. I told you that I was going to help you guys out. So let's do the trans. So again, it's the same 1-bromo 2-methyl cyclohexane. It's just going to be in the trans position. So for trans, you have to do, again, draw all of them a bold or dashed. Since it's trans, one is bold, one is dashed. And so I prefer to begin with, so since this bold is axial, then this bold that I didn't draw is equatorial. And since this trans, this dash is next to that, it's going to be equatorial, and therefore this dash is going to be axial. So I'm just kind of drawing so that way you guys are seeing where I just randomly came up with that. It's not random, I promise. So this bromine is going to be in the axial position, and this methyl group is going to be in the axial position. But remember, in the same way that both are axial, both can also be equatorial. And so that is what I depicted in this below. And if you haven't figured it out, this is even better. Why? Because both of the large groups are in the equatorial position, and so that is going to be the most stable chair. If you like this video, again, please follow me on YouTube. I have everything by playlist, so I have a lot more organic chemistry videos because I know I've been there, done that, and I know how hard it is for a lot of pre-health students, pre-health major students, because I'm pre-med, have a 4.0 like I said, and so I know the difficulty of this class. And so I have a ton of videos on organic chemistry and also other pre-med classes like biology, anatomy, physiology, general chemistry, genetics, biochemistry, etc., etc., etc. So go check that out on my YouTube and follow me in both, and thanks again for watching.